we've got our first answer coming in. It's very exciting. Keep those answers coming. I'm going to give you, I think, 2 more minutes on this one, and I'm going to go through the answer. And then we're going to move into our next type. We're going to try and zoom through all the different types today. Oh, so some people are getting x equals 2 and some people are getting x equals -2. Interesting. Very interesting. Okay. Who can tell me how we know that this equation is linear? How do we know that this equation is linear? I promise it's not a trick question. Fatu, yes. How do we know that this is linear?
Ma'am, it does not have a square.
Yes, good. There are no
It's not
squares.
square.
Excellent. All of our x's are just x's. There are no squares. 100%. Perfect. Okay. Now, if it's linear, all we have to do is we have to put x's, x's on x's on one side and numbers on the other side. Okay, so when we don't have a square, it's just linear. We want x's on one side and numbers on the other side. So the first thing we're going to do here is we're going to do some distribution. So we're going to have -32 plus 12x is equal to 5x minus 15 minus 3. Now at this step over here, you would get a mark for that distribution and a mark for that distribution. Next step, we want to get our x's on one side and our numbers on the other side. So we are going to keep this 12x over here and we're going to move that 5x over. So its sign is going to change. That's going to be -15 minus 3 plus 32. Okay. Then we're going to have 12 minus 5, which gives us 7x. And that's going to equal -15 minus 3, which is -18, plus 32, which is +14. If you got to this step over here, you're going to give yourselves another mark. Last step, when we have a coefficient of x, we divide by that coefficient and we divide on both sides. And so our final answer is x equals 2. Final mark, this is out of 4. How did we do? Let me know. Let me know how this question went. This is just trying to bring back the memory that when we have a linear equation, we want x's on one side, numbers on the other side, because we use this concept a lot in our other equation work. Ah, good. That is exactly what I want to hear. Beautiful. Okay. If you would like to take a screenshot, please feel free. From here, we're going to move on to quadratic equations. Okay. All right. So similarly, the way that we knew that the top one was linear because there were no squares, we know that this is quadratic because there is a square. It's a quadratic. We're going to follow a few steps. First step when it's quadratic is we want to move everything and we want to make it equal to 0. Second step is we are going to factorize. Third step, we are going to get 2 answers for x. Okay, so those are the steps we follow if it's quadratic. This one, in this case, it's already all moved onto one side for you. So you can jump straight to step 2 and step 3. Should be nice and easy. This is a nice, easy trinomial. There's nothing horrible about it. There's no weird coefficients. Nice, easy trinomial. Beautiful. Great start. Great. Excellent, guys. So we're going to factorize this. We're going to have x minus 3, x plus 1 equals 0. If you get to that, you get 1 mark. And then we split it up. So we say this is equal to 0 or this is equal to 0. So x minus 3 equals 0 or x plus 1 equals 0, which means x equals 3 or x equals -1. Now, is there anyone, so 1, 2, is there anyone who doesn't understand what you've seen there in pink before I give you a slightly harder one that is similar to that? Is there anyone who doesn't understand what's going on? Okay, cool. So now that we are pros, I want you to try this one. Exactly the same idea, except now this is a grade 10 trinomial, so it's a slightly harder one. Give it your best go. That's a 7, in case anyone's wondering. Just try your best. I'm going to give you a little bit of time to try and figure this one out. And then we'll talk about our answers. And then we're going to go through a couple of questions which have a few traps in them. Not horrible traps, but traps that are easy to fall into. So don't panic. This is just a trinomial. So all we're going to do is we're going to do our crisscross method. When we multiply these two together, we need to get the 6x squared. And when we multiply those two together, we need to get the -3. And when we do our crisscross, we need to get the positive 7x. So think about your factors of 6. We've got 1 and 6 and 2 and 3, and our factors of 3 are just 1 and 3. So we know that we have a 1 and we know that we have a 3. We don't know about our signs just yet, but we know that much because there aren't any other options. Okay, so just be careful with that, Marula. If we have 2x times 2x, that's going to give me 4x squared and not 6x squared. I like some of that. Samuel, I like a lot of that. If we break up the 6, okay, what we're going to land up having is if we put this 3 over here, so we have a 3x there, and if we have a 2x here, let's multiply those out, see what we get. So 3x times 3, that's going to give me 9x, and 2x times 1, that's going to give me 2x. So that means I can get 7x from that. So I want positive 9x minus 2x, which means this needs to be positive 3, and that needs to be a -1. And remember, these are our brackets. Okay, So that means I'm going to land up with 3x minus 1, 2x plus 3, and that is equal to 0. Then we do the exact same thing we just did. Each one of those brackets needs to equal 0. So 3x minus 1 is equal to 0, or 2x plus 3 is equal to 0. We're going to move that 1 over. So 3x is equal to 1, which means x is equal to 1 over 3. Move that 3 over. So 2x is equal to negative 3, which means x is equal to negative 3 over 2. Okay, marks for this question. You would get 2 marks for factorizing that correctly. And then you would get a mark for each of those answers. So we're looking at 4 marks here. How did we fare? How did we do? Did we get stuck with the factorizing? Did we manage to get through the factorizing? Oh, nice job, guys. Those of you who are getting 4 out of 4, that's insanely good. Well done. Awesome. Nice job. Okay. Oh no, Piwe, don't panic. We're going to do quite a few quadratics before we move on to our next section, okay? All right, next quadratic. This one looks deceivingly simple. Yeah, Cat, he's joined us. You think he's hungry. This question is just 3x squared minus 6x. It looks very, very simple, but it makes lots of people make lots of mistakes. Okay, so I want you to think very carefully about what you have to do for this question. Think about what it is. We know it's a quadratic because there's an x squared. So think about what steps we need to follow. If it's a quadratic, we need to move everything to be equal to 0. Then we need to factorize, and then we need to get our answers for x. So if you follow those steps, you can't go wrong. But these questions cause lots and lots of silly mistakes for some reason. Sorry, guys, if I'm moving, it's because my cat is biting the screen. I'm liking that answer a lot. So Marilla, that's a good second last step. Okay, don't panic. I promise I'll talk you through how we factorize here. Okay, let's go through this step by step. First thing we want to do is we want to move everything to one side to make it equal to 0. So we need to move this over. So we're going to have the 3x squared plus 6x is equal to 0. Okay, that's our first step with quadratics. Second step, we need to try and factorize. Now, when we factorize, we think about what we spoke about in our lesson on Monday. First thing we have to look for is there a highest common factor? Okay. If there is a highest common factor, we have to take it out. And in this case, there is, it's 3x. So we're going to take 3x out as a highest common factor, and we would be left with x plus 2, and that's equal to 0. This step here gives you 1 mark. Moving it to standard form gives you 1 mark. Then we say this equals 0 or this equals 0. And often people forget about this one. So we're going to say 3x is equal to 0 or x plus 2 is equal to 0. So here, x is equal to 0 because 0 divided by 3 is 0. or we move our 2 over, so x would be equal to -2. 2 answers. 1, 2. 4 marks. Did anyone fall for the trap and leave off this 3x over here and just get 1 answer? Or did anyone say 3 equals 0? That's another common mistake. Did anyone fall for the trap, or did we manage to get 4 out of 4? Let me know. Nice. That's okay. Okay, our next question is another one which has a very common trap. So again, remember guys, these are all like as easy as these can go, but they all have a trap that you will see in more complicated questions. So just keep that in mind. So when you have something like this that's outside the bracket, remember we can't just ignore it. All right. Okay, so this question has a very, 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 very common trap. I would like for you to solve for x in this question, please. It's already moved to one side and it's equal to 0. Daniel, I haven't ever folded an identity equation. So I'm nervous to say yes or no. It's more commonly referred to as being in standard form, but that doesn't mean that that's wrong. It's just not something that I've used. So it's very possible that it is called that. Don't fall for the trap in this question, guys. Great start. A great start, not finished though. If I tell you the trap, then when this trap arrives in a test or exam, then you're going to fall for it. But I've seen great answers popping out here. I'm feeling like happy that you didn't fall for my trap and also sad that you didn't fall for my trap. Somewhere in the middle. Okay, nice job though. So what we're going to do is we're first going to take out the 2. So we're going to take out the highest common factor of 2. And we're left with x squared minus 16 is equal to 0. And now we are going to do dots. So we have the 2x plus 4, x minus 4 is equal to 0. Now, one of the traps, so the first trap is that most people, not most, a lot of people don't do the second step. And so then they land up saying x is equal to 16. So that's trap number 1. Trap number 2 happens over here, where they look at this 2 over here and say that 2 is equal to 0. And then x plus 4 is equal to 0. Or x minus 4 is equal to 0. Now, as soon as you write this, you won't get any of these marks because it's mathematically unsound. Is it possible for 2 to equal 0? Is that something that's possible? I'm not trying to trick you here, guys. I promise. No, it's not possible for 2 to equal 0. It's like 1 can't equal 2. 4 can't equal 7. They're not equal to each other. It's not possible. Okay. And so when we have a number over there, we ignore it because we could divide both sides by 2 and the 2 would go away. So we don't write that. If you write it, you won't get any of these other marks. Therefore, we're just going to write our endpoint here. So x equals -4 or x is equal to 4. Okay. There's one sort of thing that we just need to keep in mind here. If we'd had an x, so this would be a different question, but if we had an x on the outside and not a 2, what would my answer be then? So if we were looking at that orange, what would my answer be then? So now instead of a 2, I've written an x. Come on, give it a go. Jump into the deep end, give it a guess. If it's wrong, it's wrong. Good. Yes. Nice. In this case, because it's an x and it's not a number, it's the same as like what we did in the previous question. So here we would say x equals 0, x equals -4, or x equals 4. But because it's an x and not a number. So just keep that in mind because there's a distinction between those. Okay. I do have another quadratic here, but I think you're good with the quadratics and I want us to try and get through all the others. So I think let's move down to fractions. Do you feel confident with quadratics? Can you give me like a number from 0 to 10 on how we feel with quadratic equations? Okay. All right. We'll come back to it if we have time. Okay, we're going to start with a nice easy fraction question. And then we're going to do one that's slightly more difficult. Okay, I'm not going to be giving you any hints on what to do here because you guys are brain buffs. I would like for you to fall for my traps. I have got 2 traps that I have set here. And once you have done this question, we're going to try a slightly harder one. So the 2 that's outside the brackets, basically we divide both sides by 2 and so it disappears because 0 divided by 2 is 0. So if you have a number that's on the outside, it goes away because it can be divided out. And if you have questions, just let me know. I'm here to help. Okay, I'm going to give you 2 more minutes. Hopefully that'll be enough. 2 more minutes, and then I'm going to talk through this one, and we're going to see who fell for my traps and who didn't. And then we're going to do a slightly more tricky version of a fraction question. And we'll see how we go. And then we're going to move into some exponentials and and hopefully we'll have time for at least one simultaneous equation. So we'll be able to have jumped through most of them. Lots of people getting 8 and 1 -8 so far. You got 1 more minute to finish this off. When my clock turns to 18:29, I'm going to start talking through this question. Give you a couple of hints to try and make your life a little bit easier. Okay, let's go. So firstly, when we have fractions and we're dealing with plusing or minusing, we always need to have a lowest common denominator. Okay, that's just set. Plusing or minusing with fractions, we need a lowest common denominator. If we have a whole number, we want to put it over 1. If we don't put it over 1, it's very easy for us to forget that it also needs to have the same denominator. Okay, in this case, our lowest common denominator is 12. So we would need to multiply that by 4. We would need to multiply that by 3, and we need to multiply that by 12. Another thing that helps us make no mistakes when it comes to signs is putting our terms at the top in brackets, and that is specifically going to be helpful for the next question you do. Okay, so I've got 4 times x plus 2 minus 3 times 2x minus 4 is equal to 12 times 3. And all of those are over 12. Now, as soon as we have a fraction equation that has the same denominator, so it's a common denominator across all of my terms, we get to cross it out. Okay, so I'm going to leave it there so that you know that we've had it, but we don't need to even write it. Some of your teachers may want you to write it, so if your teacher is like that, then write it in, but you actually don't even need it. Okay, now we just have a normal linear equation where we're going to do some distribution. So we're going to take that 4 in, we're going to take that -3 in, and we're going to multiply that 12. So we get 4x plus 8 minus 6x plus 12 is equal to 36. We're going to keep our x's on one side, and we're going to move our numbers to the other. So we get -2x is equal to 16. Divide both sides by -2, and we get x is equal to -8. All right, so these are my questions. First, did anyone fall for this first trap and not put that over 1 and just keep it as a 3? That was trap number 1. That was trap 1. Did anyone fall for trap 1 and not put it over 1? Okay, trap 1. Trap 2. Trap 2 was not putting this in brackets, because what you land up with then is you don't land up with a +12, you land up with a -12. So that was trap 2. Trap 2. Did anyone fall for trap 2 and get a -12 over here instead of a +12? Any trap 2 fallers? Let me know. So far we have someone who went into trap 1. Yep. Okay. Those are our 2 big traps. So in order to avoid these traps in the future, as soon as you see a whole number, put it over 1. And as soon as you have more than one term in your numerator, just put brackets around it straight away. And it'll stop you from making those mistakes. Okay. That's the whole point of maths, is trapping. It's how we roll. Oh, that's amazing. Okay, so now this is the easy version. Now you're going to do the harder version. Okay, so 3x plus 4 over x plus 6 is equal to 3x minus 2 over x minus 3 minus 21x over x squared plus 3x minus 18. My only advice here is start by factorizing and think about the traps over here and don't fall for them again. And good luck. I'll give you a couple of minutes. And guys, remember, if you have questions while you're working on it, you're welcome to put them in the chat, because then both Nelly and I can answer if we see them. And if you're wanting to ask the question out loud, just pop your hand up and then we can unmute you and talk to you. If you've managed to factorize that denominator that I've highlighted in yellow and you want to check your answer, pop it in the chat so I can confirm whether it's right or wrong, just to make sure you don't make mistakes as you move through this question. Nice job. Beautiful. Okay, so I'm not gonna do the full thing. I'm just gonna write in that step of the factorization to help for those who weren't there yet. Okay, and now my advice is put that in brackets, put that in brackets, those in brackets. And when we get to this point here, what is my lowest common denominator? What is my lowest common denominator? So this is just to help if you're struggling a little bit. What would be my LCD of this question? Can no one give me my lowest common denominator? Come on, guys, wakey, wakey. I know it's almost holiday, or for some of you it is holiday. I'm asking you to do maths late on a Wednesday evening. Yes, thank you. Our LCD is x minus 3x plus 6. Good. Good. Okay, so then I want you to think about what's missing from 2 of the fractions. So think about what you need to multiply them by. Then you're going to need to do some FOILs. I'm going to give you just a couple of extra minutes to finish this off. Then we're going to talk about it, and then we are going to jump into some exponential equations. You're doing really well though, guys. Just keep going, keep plodding along. I know these questions are long, but they're worth so many marks that they really are worth like doing carefully and slowly. Okay, so what's missing from this first one is x minus 3, and what's missing from the second one is x plus 6. So we're just going to multiply those up. So we have 3x plus 4 multiplied by x minus 3. That's why those brackets are so important. That's equal to 3x minus 2 times x plus 6 minus 21x. Now, all of that would be over the same denominator, so we don't need to write it because it is a fraction equation and it would drop. Okay, now we are going to do FOIL. So we're going to multiply everything by everything. We're going to get 3x squared minus 9x plus 4x minus 12 is equal to 3x squared plus 18x minus 2x minus, oh goodness, not 18, 12 minus 21x. Okay, so mark-wise, so far you would have gotten a mark, okay? You would have gotten a mark for doing that factorization. Then you would have gotten a mark for showing that you knew to multiply that by x minus 3 and that you knew to multiply that by x plus 6. You'd get a mark for doing the correct FOIL there and a mark for doing the correct FOIL there. Now, when we look at things, if we have a 3x squared on this side and a 3x squared on that side, they would cancel each other out because 3x squared minus 3x squared just goes away. Okay, so then it just becomes a linear equation. So we want to get our x's on one side and we want our numbers on the other side. So I've got negative 9x plus 4x minus 18x plus 2x plus 21x is equal to negative 12 plus 12. Is anyone unhappy at this point in time? Let me know. Before I do this last little step, let me know if you're currently displeased. Okay. Let's work this out. Negative 9 plus 4 minus 18 plus 2 plus 21 gives us 0x is equal to negative 12 plus 12, which is 0. What on earth do we do now? What on earth do we do now? Who has seen this in class and who knows what to do? Beautiful, yes, XER. X is any real number, or you can write x can be anything because it doesn't matter what value x is. If x was 1, 0 times 1 is 0. If x was 2, 0 times 2 is 0. And x can be anything and it would be equal to 0. So we can write x is an element of any real number, or you could say x can be anything. Okay, what happens in a similar situation, if we have a slightly different question, what happens if we had if our x's canceled out completely and we landed up with something like a 0? So let's write it like this. Let's say I had x minus x is equal to 12. So x minus x is 0 and that's equal to 12. What would I do in that situation? Yeah, keep your answers coming. What would I do in that situation? How would we finish that equation? We could just say, we just need to write one last line over there. All we need to say is, therefore, not possible. That's it. So nothing fancy. We're basically just saying it's impossible for 0 to equal 12. That can't happen. So we could just say not possible. That's it. So those are like our two different sort of sneaky types of equations that you can be given. So one where 0x is equal to 0, and then it would be x is any real number, or if we have 0 is equal to a number, then we just say not possible. Okay. Or no solution. Depends on how you've been taught it at school. Cool. Nice job, guys. Screenshot if you would like to take a screenshot, and then we are going to quickly zoom down to some exponentials. Hopefully we can get through the 2 easy ones and 1 complicated one before our time is gone, but it is running away from us. Cool. Okay. Exponential equations. The key to exponential equations is to make sure they have the same base. Okay, so what I mean by that is if I have the number 2, I need to get it to have a base. If I have the number 8, I need it to have a base of 2. So 2 to the power of 3 is 8. If I had the number, let's think, 125, that would be 5 to the power of 3. Okay, so we wanted to get its prime bases. Remember, you can always use your calculators to help you. So in this case, you can write 27 equals shift fact, and you will get its prime base and its power. Okay. Try work this one out. Tell me what my answer is. Put your answer in the chat. This is as easy as these ones can go. The next one is 1 level up higher, and then the next one we're going to do is going to be a little bit harder. Okay, getting some answers in. So fact is on your calculator. It's this button over here. It says fact in yellow, and just below it, it's like there's a dot and then like almost 2 commas, if you look for that. It's basically telling you it's going to give you its factors. Okay, lots of answers coming in. So to get this 27 to have a base of 3, it's going to be 3 to the power of 3. So we're going to write that as 3 to the power of 2x plus 1 is equal to 3 to the power of 3 to the power of x. Now, the reason I'm writing that in brackets is because it'll help us in one of our later questions. If you went straight to saying 3 to the power of 3x, that's fine. Okay. When we have a power to a power, we multiply. So that's going to be 3 to the power of 2x plus 1 is equal to 3 to the power of 3x. Now, when we get to this point here, as soon as our bases are the same, we are allowed to make our exponents the same. So now we are allowed to say 2x plus 1 is equal to 3x. I'm going to move that 2x onto this side. And so I'm going to get the answer 1 is equal to x, or x is equal to 5. Okay, so this is as simple as an exponential equation can get. We're going to do a slightly more complicated one now, and then we're going to do a more complicated one than the next one. But let me know if you have questions or if there's things that you're not understanding so that I can help sort of help you out a little bit. All right, next one. I am wanting you to solve for x, please. Think of the same rules. We need them to have the same bases. Once they have the same bases, then our exponents can be the same. all of this will be in the quiz tonight. So all of the expression work we did on Monday, and then all of these different equations that we did today. I'm going to write the next one up on the board for those of you who are feeling confident and have finished this one, just so that you can give it a go, so that you don't have to rush. So if you're feeling confident, you can give that one a try. I'm just going to give everyone another minute to finish off this, and then we'll move on to the one that I've just written on the board. Okay. So this one on the left-hand side, the first goal is we need to get this 64 to being a power of 2. And that would be 2 to the power of 6. And then just think about your exponent laws. If we want that base to be up at the top, all we need to do is we need to make that exponent negative. So we're going to say 2 to the power of 3x minus 4 is equal to 2 to the power of negative 6. And if you are uncertain, you can just put that in your calculator exactly like that. So 2 to the power of negative 6, and you push equals. And if you don't get 1 over 64, you would know that you are wrong. Okay. Now our bases are the same, which means our exponents are the same. So 3x minus 4 is equal to negative 6. I'm going to move that 4 over. So 3x is equal to negative 6 plus 4. I think what a lot of people did is they changed that to 2 to the power of 6, but they didn't think that it needed to be negative. So just be careful with that. That is a very normal trap. So we land up with 3x is equal to negative 2. Divide both sides by 3. And so x is equal to negative 2 over 3. Okay. Give the one on the right-hand side a try. Try and not fall for the same trap. If you left that as 2 to the power of 6 and not 2 to the power of negative 6, then you fell for my trap. So just be careful to not do the same when you tackle 1 over 32. And this will be our last question of the evening. So you can turn your brains off after this. So use all the brain power you have left to finish off this question. I'm going to give you 1 more minute, and then I'm going to need to start talking through it just because of our time. Oh, I got our first answer coming in. Okay, step 1, get everything to have the same base. So we're going to say 2 to the power of x times 2 to the power of 4 to the power of 2x minus 3 is equal to 2 to the power of negative 5. That's step 1. Step 2. This is why I said that bracket can be helpful. We're going to distribute that 4. So we're going to have 2 to the power of x times 2 to the power of 8x minus 12 is equal to 2 to the power of negative 5. When we are multiplying and they have the same base, we are allowed to add exponents. So we can say 2 to the power of x plus 8x minus 12 is equal to 2 to the power of negative 5. So in this case, we don't need to worry about the fact that it's over 1 because anything divided by 1 is just itself. So we don't need to write it in. I'm going to simplify that. So we have 2 to the power of 9x minus 12 is equal to 2 to the power of negative 5. Now our bases are the same, and so our exponents are the same. 9x minus 12 is equal to negative 5. Therefore, 9x is equal to negative 5 plus 12. 9x is equal to 7, which means x is equal to 7 over 9. And I think I did see someone who got that answer, which was really great.
Yeah, I think it was 10 to